Hi everyone. What are containers for? In order to get the knowledge of containers, I strongly believe that you have to know the history of applications and servers architecture. So in this session, I'm going to talk about the history of the evolution which has happened to servers and applications architectures. Okay, what is this? This is the theory of evolution to uh, humans. So you might ask, okay, what it has to do with containerization? We have got the same evolution in the computer history and software architectures as well. And this is an abstraction picture of what happened to computer software evolution. As you can see, developers started from mainframes and ended up to containerization. So the servers got became more complicated and uh, more useful during the last couple of decades. It was what happened to software architecture as well. Okay, what is this? This is a typical server room in which I used to work 25 years ago. So what we had in bad old days, actually it's not too much old. What we had was actually uh, specific and dedicated servers for each application. So if we wanted to have a service such as mobile core service to be delivered to customers, we were using kind of infrastructure. And that infrastructure was consisting of CPU, RAMs, memory, and motherboards, and even inventors and converters on which, on top of that, we used to have our operating system, which could be a Solaris, Unix, or mm, even a Linux machine. And on top of that, we could have our application on which I have shown here with its relevant binaries and libraries. So everything was running on one server, and that server was dedicatedly being used by that application. What is monolithic application? Monolithic application used to run in a server like this in old days. So something which was wrong about those monolithic applications where if anything happened to any of those servers, we would have lost our service. So we needed to have couple of servers as a backup servers. Besides that, we also had to have a full server resources being available all the time. So regardless of the amount of load on top of each application, we had no choice rather than running a server with all resources. So imagine that in the peak times of a day, for example, we could have used 80% of the uh, load of the application, and during the night we just had maybe 10%. Although we just had 10% of application load, we still required to have whole the server running, which was causing a lot of efficiency issues. So in order to not have such a drawback about efficiency, we had no other choice than turning on and off those servers continuously. You can see an angry engineer which has been frustrated of looking after those monolithic applications. What happened in the early 2000s was inventing of virtualization. Although there was a kind of virtualization and isolated processes existed by Solaris, but virtualization, which has been introduced by companies like VMware, was a game changer. Now let's talk about virtualization. This is a virtualized data center. So the first time I heard about virtualization was when one of our telecom vendors introduced server pooling. In a typical virtualized server room, we had our infrastructure, which was consisting of couple of or sometimes many servers, and on top of our infrastructure we have our hypervisor type 1, and those hypervisor type 1 having their own guest operation systems which are serving to different applications. So we could have one server in this case, and we could use that sole server resources to create couple of applications in an isolated conditions. As you can see, these applications and their operating system are isolated from each other. So they are just on top of one hypervisor. It is very useful in conditions on which we have a couple of servers which are using as a cluster, and on top of that cluster, we could run many applications. It will give us more availability, scalability, and provide more efficiency. That's the system that even these days being used by public cloud providers like AWS, Azure, and Google Cloud as well. In the end, we had more happy developers. Definitely looking after those virtualized environment was much easier than monolithic servers because developers had more control on those applications and all the resources, and they could use the resources more efficient than before. Here I have provided virtualization's drawbacks as well. So definitely these hypervisors and these technologies and the companies which are offering them are not offering them for free. So cost is a big deal for them. The other thing is the limitations because many of the old applications or obsolete applications are not capable to be run on virtualized servers. The other problem was availability issues. If anything happened to the underlying host machine, which is hosting those virtual machines, we will lose our virtualized environment. So we need to have high available infrastructure. Scalability issues is utilization of resources higher than what it is needed. The other drawback is complexity. So running these uh, vCenters and virtual machines and hypervisors are sometimes very complicated and need specific skill sets. Another drawback is the dependency. So sometimes once you want to run those virtual machines, they have specific dependencies which has to be met. And the last and the most important drawback is the security risks because we are using a shared infrastructure. Although we have more isolation in compared to containers, but still security is a big issue in virtualizations. That's why I highlighted limitations and security risks because I believe that we might have these issues more on containers than virtualized machines. Finally, we could reach to containers. Okay, this is a container, a real physical container. Why we use such a container? We package our stuff inside that in order to get it ready to be carried by a ship or a trailer. So we use the same concept for containerized application as well. This is a containerized application. So we package all the libraries, binaries, and all the necessary things for an application, and we package them inside a container, exactly like a real container. Here you can see once we packaged our applications inside the container, then we can put it on top of a ship. In this case, we call it a container engine, and we can carry it to wherever environment we would like to have. So this is an abstraction to say, to show you what container engine and a container can do for us. In this picture, we can see we just have one container uh, on top of the container engine, which is a ship here. Most likely, it is a Docker engine. We don't have to just use one container engine or ship for each container. Sometimes we are moving many containers by a container engine. Just like this picture, you can see there are lots of containers which has been moved by a very big ship. This is the depiction of containers. As you can see, we got our infrastructure. On top of that, we got our operating system, which has got its container engine. And this container engine is just that ship which is managing and moving those containers. So application one and all is binaries and libs will be managed by this container engine. And all those applications are actually running on top of one operating system. Most of the time, we just have one Linux server or a virtualized Linux operating system. And on top of that, you have many containerized applications which are sharing the same resources and infrastructure. This makes the job for the developers much easier because we don't have the complexity which we had before with monolithic applications. And most of the time, these applications are microservices. This is microservices. You can see the database, the file storage, and many applications are running all together and they need to communicate with each other. So the container engine, for instance, the Docker engine, will look after these communications between these microservices. The microservices architecture is an architecture which is very popular these days. So instead of having couple of servers, such as a three-tier application uh, architecture, we could have many microservices in one in a service, and all of those microservices are in contact with each other or with the necessary and relevant microservices, which cause more efficient and useful applications. Although we can have these microservices to run on top of virtual machines, but m- most likely you will see such an architecture in a containerized environment. And thanks to container engines and containerization, we can have these microservices. In the end, let me have an overview of what we have learned in this session. I have talked about old days, so as you can see, just like the depiction on the left-hand side, in old days we just had a server and applications and its dependencies running on top of one operating system, and that operating system was running on top of one infrastructure. After that, having virtualization, we could have separate virtual machines running on top of one infrastructure. It was offering us more isolation for applications and making the job of running uh, the job of DevOps much easier. And finally, we had containers. On containers, we got an infrastructure on which we will have our operating system and relevant container engine. That container engine could be Docker, CRI-O, Containerd, or even anything else. And on top of those container engine, we have compatible containerized application with that container engine. And that container engine, which sometimes called runtimes, will look after those applications. As you can see in the right hand side depiction, uh, you can have application 1, 2, and 3, and those applications are using the same container engine and the same operating system and shared infrastructure. This will cause much efficient and much easier maintenance and development of those containerized applications. Thank you for watching me. I will discuss more about containers in next videos.